Okay, so example problem is I already gave in my lecture note. So it says that the switch has been in position 1 for a long time. Okay, notice this, long time. These are all terms to indicate steady state, DC condition, something that is not changing. Right. So position 1 for a long time. So this means it is connected this way. At t equal to 0, the switch moves from 1 to 2. Okay, switch goes now to 2 at t equal to 0. Now what we want to do is typically calculate I of t. What is I of t? I of t is the current that is going into the resistor, 3 ohms, right? This is the convention. This is what you are asked to do. First question, what does for a long time mean? What do you understand by long term? Long time. What can we do to the circuit? Yes, anybody? What happens in a steady state before the switch is moved, right? What simplification can I do? Yes? Very good. Capacitor is open circuit. You agree? It's a DC condition, steady state. Capacitor offers infinite impedance. Capacitor 0 circuit. So I remove it. So clear? Long term means before I short, capacitor is open circuit, right? Now tell me what is the voltage on this net? Now it's very easy, right? You have 12 volts here, and you have 3 kilo ohms and 6 kilo ohms. So it's R1 by R1 plus R2. So by plus 6, 3. Okay, so 3 by 9 into 12. So approximately about 4 volt. Okay, so this is about, you see about 4 volt here just before you turn on the switch to move the switch. So is this clear? Now it's a simple exercise. 12 volt, 6 kilo ohm and 3 kilo, right? What is the current now? We are asked to do a current, right? I of t. What is I of t? 4 volt divided by 3 kilo ohm. So you agree? This is 4 by 3. So current in this is simply 4 by 3 milliampere. So everybody agree? Everybody with me so far? What I've done is I've not done anything after the switch turns. So I'm still looking at when switch was connected in original position, right? In that original position, because I want to estimate the initial condition. Why I want to estimate the initial condition? Because whatever was the voltage across the cap, it should start from the same voltage after the change also, correct? Capacitor is lazy to change its voltage. The initial voltage of cap should remain the same. Okay, it's clear? Now, so we know that the initial voltage of the capacitor is 4 volts. Right. Let's now connect the switch from position 1 to position 2. Okay. So now what is happening now? The capacitor which has a 4 volts will now discharge because you have 6 kilo ohm and 3 kilo ohm. So now tell me, is 6 kilo ohm in series with 3 kilo ohm or is 6 kilo ohm in parallel with 3 kilo ohm? Yes? Parallel. So do you all agree? Does everybody agree that when you have this 2 kilo ohm connected, then it is basically 6 kilo ohm. This entire thing comes in parallel with 3 kilo ohm. Okay, because the current gets shared. Whatever is the cap, the current gets split between left and right, and it comes back to the same thing. So it's a parallel combination. So what is parallel combination of 6 kilo ohm and 3 kilo ohm? Can somebody tell me? Kilo ohm. 2 kilo ohm. 6 into 3 by 6 plus 3, so 2 kilo ohm. Okay, so I have a capacitor. I've been given this value. So 100 microfarad is now discharging across 2 kilo ohm. So what is the discharge equation? I start from 4 volt. I am now going to 0. Ultimately, what happens to VC at infinity? After infinite amount of time, what is the value across the capacitor?
0, sir.
Everybody agree on this? Does everybody agree that ultimately the capacitor should get discharged completely by the resistor and go to 0? Why? Because if this was non-zero, right, then there will still be some current across the resistor and it will keep discharging further it will keep discharging. So does everybody agree that at t equal to infinity, right, capacitor voltage should be 0? Yes or no?
Yes, sir.
So what is the current in 3 kilo ohms? When capacitor voltage becomes 0 at infinity, what is the current at t equal to infinity in 3 kilo ohms? 0, correct? Voltage across 3 kilo ohm is 0. That's the capacitor voltage. So the current started from 4 by 3 milliampere initially and will go to 0, right? So you can now almost plot it. 4 by 3, and somehow it's going to 0. What is the time constant? Time constant is R effective into C, right? So whatever is the capacitor, the R effective is 2 kilo ohm. So 2 kilo ohm into C. The time constant is R into C. So 200 into 10 power minus 2. So about, what does this come with? 10 power minus 4. 200, 10 power minus 3. So about 0.2 seconds, right? T will be 0.2 seconds. So it is R into C. Right? This is 100 microfarad into 2 kilo ohms, right? Is this correct? 0.2 seconds. Yes or no?
Yes, sir.
Yes. Okay. So what does the solution look like? So you basically have this one long term, and then as soon as you connect, you can do all that equation. You can now do conventional equation, right? Write down your differential equation, short it. So let's assume this is V of t. So V of t by R1 plus C dV by dt, the current going to the capacitor plus the current going to the resistor, all of this equal to 0, Kirchhoff's current law. Or in other words, 0 minus V of R1. So whatever is current going into this, the current flowing into the net should be same as current flowing out through R2 and C, right? This is your equation. And once you solve all the equations, you'll basically see it starts with 4 by 3 3, it will go down to 0. And your tau is going to be a parallel combination of R1, R2 and C. Okay? So it's R1, R2 by R1 plus R2 into C. When you do that, that is a time constant. So you basically have, when you simplify this equation, you get dU by dt is equal to 5 Vt. And you can solve this. Basically, you get an exponent. The tau is R effective into C. And why is R effective? That is because capacitor, so this is a short, a 2 is short. So the 6 kilo will come in parallel with 3 kilo ohms. So this is a parallel combination because the current will get shared on either side. So it's basically comes in flat. Okay? So this is 6 kilo ohm parallel 2 kilo ohm. This is 2 kilo ohm into 100 microfarad about 0.2 seconds. Right? So now it is clear. The voltage starts at 4 volt and it is decaying with a time constant of 0.2. Very easy to write the equation. V is equal to initial voltage, which is 4 volt into e power minus t by tau. Tau is 0.2 seconds. So this is the equation of V of t. What did they ask us? They are asking us to calculate the current, right? So this is simply V of t by R2, which is 3 kilo ohm. So you come up with a 4 by 3 e power minus t by 0.2 milliampere. So just 3 kilo ohm, right? Very simple. I mean, you don't need to do even the differential equation. If it's a single first order system, calculate the initial condition, find out the final condition, and now look into the effective time constant and then solve it. Okay? You will get the same answer if you go through all the differential equations. You can apply Laplace transform. Those of you who are interested, apply S transform, do inverse Laplace, find everything, but ultimately you end up with this. So very simplified way of solving it. And if you solve intuitively, right, you understand your time constants, understand the parallel series combination. This is very powerful. You will never make a mistake, right? Intuitively. So and cross check your values always. So at t equal to 0, okay, when you have t equal to 0, what is the expected current in this? 4 by 3, right? 4 by 3. So and that is what you get, because you have 4 volts on the capacitor, 4 by 3. At t equal to infinity, current is 0. So e power minus infinity, it is 0. This kind of follows intuitively your numbers. So please always check intuitively at t equal to 0, at t equal to infinity, whether the answer you are getting somehow matches what you expect, right? It's a cross check. Okay? Now sometimes, if you appear for a gate entrance examination, they'll give you multiple choice questions, and it's a lot more easy. Sometimes you don't even need to solve it. Put t equal to 0, put t equal to infinity, you can eliminate all the random answers directly, right? Very easy to solve it. But in our case, we expect you to solve it. So this is a easier way to do it. Yeah?